Hello, everyone. Here is the review video for Unit 2. Share the screen so you guys are looking at the right problems. It might not feel like it, but we're almost through all of first semester's material. You guys are doing awesome. So good stuff. Let's get my pen to work and get right to it. Unit 2 is pretty big, right? So we're going to cover a lot of stuff. Right here, I know the mistake people are going to make is we're going to look at this and start multiplying. We've got a plus sign and a minus sign here. So we got to recognize we're basically just lining up like terms here. With the plus, you don't even have to change anything. Minus 4x squared goes with 2x squared. The 6x will line up with 5x in the 3 right here. 2 minus 4x squared. I like to combine them. So that gives me negative 2x squared. 5 and 6 make 11 x's, positive 11x. Negative 7 combined with a positive 3. I have more negatives. How many more? 4 more. I'm already in standard form, so no need to rearrange them. With this one, with subtraction, I would say instead of subtracting everything, just distribute that negative and then you can just combine like you did before. Distributing that negative is going to change everything to its opposite. So instead of 8x squared, it is now negative 8x squared. Instead of negative 4x to the fourth power, it is now positive 4x to the fourth power. Instead of positive 1, it is now negative 1. That positive 4x to the fourth power is going to go over here. 8x squared, there's nothing to combine it with. I'm just going to circle it so I don't forget about it. I don't know if that's a great method, but for now, it's just something I feel like I'd forget if I just left it there. Negative 1 goes here. Oh, see, I'm already forgetting. I combine the 4x and the other 4x, the fourth power. That gives me 8x to the fourth power. Negative 8x. There's nothing to combine it with. 4 minus 1 is 3, positive 3. I circled this. The reason I circled it, there's nothing to combine it with. I am not even close to standard form here, right? So let's rearrange this. 8x to the fourth power minus 8x to the second power minus 8x. I wonder if we did that on purpose. And then add 3. Okay. Let's go with red. Box method, you can use box method like a basically make this into, well, actually, when there's only one thing to distribute, I really don't usually use the box method. If you do, that works. 2x times negative 2x is negative 4x squared. 2x times 3 is 6, positive 6. What I meant by you can use the box method, you can do a 1 by 2 box and get the same result. So if you've had a lot of success with that box method, you might want to stick with it, especially if you forget to distribute that second term, which a lot of people do. Either way, your answer will be the same. We did a ton of these, so I'm excited to see you guys and your success on them. X plus 7, and yes, I could have put x plus 7 down the left-hand side. Regardless of where you put it, you just make sure that there's two terms here, x times x, x squared, 7 times x, 7x, 9 times x is 9x, 9 times 7, 63. everything's positive here, so I don't have to worry about subtracting and combining negatives. So I just bring out my x squared. There's nothing to combine it with. 9 and 7. Remember, on the inside, we're adding those. So that'll give me 16x. We already multiplied 9 and 7 to get 63 on the outside. 9 and 7 multiply to be 63. They add up to be 16. So my final answer right here. So just be careful if the question is actually showing if they want to multiply or if they're separated by addition or subtraction, that means we're adding or subtracting. Sometimes I just get nervous to see if I'm recording. It says to pause recording. So that means I must be recording if there's something to pause. See my logic there? All right, the degree here is 2, tells me that I'm second degree. Lead coefficient, there's nothing in front of that first term, so my lead coefficient is 1. The constant is -3. Terms 1, 2, 3. I have 3 terms. This is a quadratic trinomial. Right, this is already in standard form, so my degree, top one, 3. The lead coefficient is 11. Constant, there is no constant, which means my constant is 0. You also write number 0. Terms, there's 2. This, since it's degree of 3, is a cubic. There are 2 terms, so it is a cubic binomial. Degree 2, lead coefficient 4, constant 0, terms 1. We have a quadratic monomial. Like a monologue is someone speaking all alone. A monomial is a term all by itself. Degree 5. Lead coefficient, there's nothing there, which means there's a 1 silently or invisibly hanging out, I should say. Constant, 1 at the end. Terms 1, 2, 3, 4. 4 terms, which we would say a 5th degree for term polynomial. Onward. This is bringing all the things we kind of did together, right? We're worrying about end behavior, we're worrying about zeros, all that stuff. So basically everything we've done this unit encapsulated in one type of question right here. So I want us to know what the lead coefficient is. I want us to know what the degree is. Why? Because those things are going to lead to me knowing the end behavior. Okay, the lead coefficient, there's a -2 out in front, which means it's -2. What does that lead coefficient tell me about the end behavior? That tells me that I'm going to go down when I'm going to the right. The degree, I have a 3 and a 2. 3 plus 2 is 5, which is odd. So in the other direction, we're going to go the opposite way. I did this again. I did this during class too, which means to the left, I will go up. Sorry about that. Okay, if it helps you, just think to the right side, we're going to be down here. The left side, we're going to be going up. All right. I hate when this happens because it's tough to switch the slides. I'm getting better at it though. All right, so let's figure out our zeros. So our zeros, and that is, what is x equal when y equals 0? We're going to say what their multiplicity is. Forgive me for abbreviating there. And that, what will that cause to happen? Okay, x minus 3 equals 0. A little mad at myself for covering up that degree, but x minus 3 equals 0. That will give me a 0 of x equals 3. It's opposite. So the 0 is 3. The multiplicity, because that kind of invisible 3 there now, is a 3, which is odd, which means we will cross when x equals 3. X plus 7 equals 0, which means x negative 7 will be our other 0. It has a degree of 2. The degree matches the multiplicity. Oh, that was multiplicity and matches put together. Or just a snobby way of saying matches. It matches, lad. 2 is an even number, which means we will cross. Okay, so personally, I like to mark my zeros when I figure them out. So I would go to 1, 2, 3, mark it. Negative 7, 1, 2, 3, 4, 5, 6, 7. That negative 2 is not going to impact the zeros. It is, however, going to impact the y-intercept. So the y-intercept, I'll have to do negative 2 times negative 3 to the third power times 7 squared. Now, where I started this, I almost didn't grab my calculator. I was like, why would I need it? I'm like, you know what? Maybe I will need it. All right, negative 2. Although your calculator is not going to help you that much if you try to use it for negative 3 to the third power. Well, maybe it will. Negative 3 to the third power. It tells me negative 27. That's right. Times negative 2. So negative 2 times negative 27 times 49. I'm guessing people don't know that off the top of their head. I certainly don't. Big old number, 2646. We appreciate 2646. 2646. There we go. All right, so I'm going to mark it right here. I can hear Savannah saying it. Why is this 2000? Oh, Cunningham. Should be positive. That's not what Savannah would say. Savannah would say, why is that 2,646? Because I said it is. Anywho, sorry about the wrong y-intercept there. Okay, I like to go, forget if I like going left or right or more. Okay, so negative 7, I'm going to bounce, right? So I'll just start there. Let's make it green. Get to that negative 7, bounce on up. If I would have kept my y-intercept incorrect there, I probably would have had my 0 incorrect and I would have headed toward it. That would have thrown me off. Okay, so now that I have my y-intercept correct, I know I have to go toward it, cross, and then at positive 3, it says I was going to cross. So I need to cross and it connects me with that end behavior. Right. Hey, that was so fun. Let's do it again. Play the game. All right, lead coefficient. Got 1 times 1 times 1 times 1. So it's a positive 1. My degree. Again, that's like saying x to the first power. These are all to the first power. 1, 2, 3, 4. We have degree, which is even. Sorry, I forgot that lead coefficient because it is positive. That tells me to the right, I'm going to go up. even, that means they're both going to go up, up, kind of like a parabola that goes up, up. Okay. Let's make our zeros green this time, shall we? Our zeros, it is where, what is our x equal? 4 zeros, we need the multiplicity. Messing up on my tables. In the effect. So kind of ugly there with this. So I'll go from left to right here just because I want to emphasize, hey, if x is all alone or if it has just a number multiplying by it, right, that's going to give me a zero of 0. That's going to be, I'm just going to, right now, before I even leave it, that's going to be my y-intercept too. Okay, because the origin, that's a y-intercept as well as an x-intercept. Okay. Y-intercept is 0, 0. So I'm skipping ahead there. All right, so what's going to happen at the origin? Well, it has a multiplicity of 1, which is odd. So I know that'll cross. -9 is my other 0. All of these are odd. They will all cross. Not just that 9, 3, and 5 are odd numbers. That doesn't actually matter. It matters that their multiplicity is all odd. -3, odd, cross. -5, odd. So I'm glad I didn't need a lot of room for my y-intercept. Reason being, everything times 0 is going to be 0. Glad I didn't need a lot of room because kind of out of room. So I'll mark that origin there, and then let's mark the other zeros. That would be +9, 1, 2, 3, 4, 5, 6, 7, 8, 9. -3, 1, 2, 3. -5. I'm going up, up, right? So let's get up. Get on up. To bring my end behavior really over to the end because I've got my the 0 of 9 there. Okay, so the good thing about having a bunch of odds is you just cross, boom, cross it, head back to the other one, cross it, back to the other one, cross it, back to the other one, cross it, and the end behavior should match up with everything you said was going to happen before, which it does. All right. Whew. It's tough, a lot of work. Okay, 4x, that's like saying, hey, 4x equals 0. 4 times what equals 0? 4 times 0 equals 0. The multiplicity is 1. It makes it odd. It will cross. These are the ones that most people are going to miss. I shouldn't say that. That a lot of people forget to do 3x minus 2 equals 0. You can't just do the opposite here. You got to do some work. So you got 3x equals 2. Divide by 3 on both sides. The other ones you can eyeball the other one, but you can't eyeball a two-step equation. At least I can't. All right, so 2/3 is my 0. But Mr. Cunningham, that's a fraction. Fractions are numbers too. Multiplicity, the degree was 2, which is even, which means we will balance. And then when you got your one-steppers here, x plus 7, right? I'm cool with you just eyeballing that, but I will show you where this answer comes from, right? Because we're saying what is the x value when y equals 0. So our x is -7. We have a multiplicity of 3, which is odd, which means we would cross there. So x squared, again, what squared is 0? Well, gets 0. So the 0 of x squared gets 0. The multiplicity is 2, which is even, which means we bounce. 2x plus 1 equals 0. Two x equals -1, divide by 2. X equals -1/2. -1/2. It's being brought, oh, we don't see this too often, to the 6th power. So a multiplicity of 6, which is also an even number, which means it'll bounce. X plus 3. Whew, finally, I got one. I can just look for the opposite. -3. 5th degree, which is odd. We'll cross. All right, now a little bit of thought. I'm going to go into these ones. Not that we weren't thinking before, but let's look at what's going on here. All of the zeros and whether the multiplicity is even or odd. So I'm going to list them. Well, I'll just mark them here, but I want to make a list. So my x equals -3. That is even. Why? Because it's bouncing. X equals -1. It is odd. Why? Or maybe I'll just write that it bounced. The even one, that is. Odd will cross, right? See how we crossed here? We bounced there. X equals 4. It's odd. How did I know this was odd? Because it crossed. Lead coefficient. I don't have an equation. How can I know what the lead coefficient is? Well, I can look to the right and I see that this end behavior is going up. So I know that the lead coefficient is going to be positive. Are you positive? Yes, I am. Such jokes are so good. All right, the degree of the polynomial is even or odd. Okay, I looked to the right. I saw it's going up. That's positive. On the other side, I'm also going up. So if I'm going up, up, that means both things are happening, which means that it is even. How do I know? Because both ends going in same direction. Right, I'm going to flip back to that slide because that's going to help me answer this question. All right, because Megan making multiple claims here. Megan claims that x equals 4 is a 0 with a multiplicity that is even. All right, so x equals 4 is even. Okay, so that's a statement we're going to contend with. Do different colors for each statement. Okay, the leading coefficient is negative. So she also says the lead coefficient is negative, and that the degree of the function is odd. Degree of function is odd. Now, this might seem an odd way to go about this. Bear with me here. Okay, x equals 4 is even. Well, let's go back to the slide. We just said that x equals 4 was odd. Why? Because we crossed. Okay, so do we agree with this statement? Disagree. Because graph crosses at x equals 4. Lead coefficient is negative. Let's look back again, shall we? We said that the lead coefficient was positive. How did we know that? Because we're going up in the right direction. So we also disagree with this statement. Disagree. Because, so don't just tell me you disagree. Tell me why you disagree. Because graph goes up. Don't pause on me now. We got one question left. Don't break on me, pen. Degree of the function is odd. We're going up, up, both in the same direction. So sorry, Megan, but we don't agree on any of this. Disagree. Why? Because end behavior is up, up. There's other ways to say it, right? They're both going in the same direction. You could say it like that, but all right. So we found not only that we disagreed with three things, we also made a statement there. I think that's the last question. Yeah, last question. Okay, so good luck on your test. If you didn't get these right, do this again and again and again until you get it right. Test is on Monday. See you in class.